All right, welcome to our last video of Unit 8. This one's on actually using reaction mechanisms. Last time we had an idea of what they are, now we're going to actually use them. So the reaction mechanism for reactions are typically a series of elementary reactions that are often numbered, and often with an indication of whether the reactions are relatively slow or fast. They're a list of these steps that a reaction will take. That's basically what it comes down to. So we're going to start seeing some of those lists. Keep in mind, elementary means it'll happen in one step. Number just simply means step 1, step 2. And slow or fast, well, you'll see in a bit. Our rate law, first off, will be determined off our slowest step. Okay? And typically, we call that a rate determining step. So a classic example of this would be, well, this. Let's pretend that we have a very strange street, if you will. And this street, for some reason, has two toll booths. Okay? The size of the rectangle represents basically the size of the street. This can typically go pretty fast. When you leave the toll booth, you got another long section of maybe like a freeway or something. You eventually get to this toll booth, but now you're on kind of like a 1 or 2 lane road. This is likely going to be our slowest step. Okay? This is what basically will make our reaction go slower or faster. For example, you may go really fast here, but if this is slow, it's going to make the whole thing slow. However, if we're somehow able to make this very fast, then our whole reaction can speed up. It's like traffic jams. Once you clear up that jam, everything else goes fine. That is what we call a rate determining step. It's typically your slowest part, because that's really what kind of slows everything down to whatever speed it's at. In general, to increase our reactions rate, all we got to do is just increase the rate of our rate determining step. Keep in mind that's our slowest step, and that's really where most of our work's going to come off of. So take your slow step, figure out how to increase it, which is, rate laws, and then you can figure out how to increase your whole reaction. To determine our rate law from a reaction, we have the following steps. First off, determine which step is our rate determining step. That's easy. Typically, it's going to have the word slow next to it. Okay? Commonly, like that. And we'll know, all right, that's our rate determining step. Done. Second off, the reactants in that step are the reactants in our rate law. Thus, and what's weird is actually their coefficients are their rate orders. So this is where the balance equation does actually help with our rate orders. For example, if we found our slow step was 2a plus b producing c, or something else, really don't care about the products, then our rate law for that would be a squared b. Well, rate equals k, etc. That's it. Just coefficients become our rate orders when you're in a reaction mechanism. And actually, you can actually always do this based on if you've got an elementary step, like if it's just occurring in one step. But again, most of the reactions we deal with don't, so that's why we can't normally use balance equations. Oh well. And to find a balanced equation from a reaction mechanism, just add up the reactants and products from all the reactions. Put all the reactants together, put all the products together, and just cancel out whatever shows up on both sides. Basically, you'll figure out, all right, this is step 1, this is step 2. So then you tell me, well, if step 1 and step 2 then happen, here's ultimately what we end up with. Just kind of combine them together. One final type, though, of substance that we can see in a reaction mechanism is a catalyst. We've talked about those before. Basically, a catalyst will come in as a reactant and will leave as a product. Okay? This means that if you have something that comes in as a reactant and leaves ultimately as a product, somewhere else, that's a catalyst. We've already talked about intermediates. They're things that are products in one reaction in the other. So basically, if something's a reaction somewhere and a product somewhere else, that's a catalyst. However, if it's a product somewhere, then a reaction later, that's an intermediate. Either way, that means it appears on both sides of the equation, which means it won't show up in our balanced equation, But our reaction mechanisms are able to actually show us really what's going on and gives us a better idea of how a chemical reaction really is actually taking place. All right, let's get some practice. For the reaction mechanism below, and by that I mean to the right, sorry, identify all the intermediates, identify all the catalysts, determine the overall balance reaction, and determine your rate law. Well, kind of forgot one main thing, the arrows. Try this real quick, spend a few minutes, come on back. All right, so for A, intermediates are somewhere where it's a product somewhere and a reactant later. We have two of those. We have X and Y. Because notice, X is produced here and reacted here. Y is produced here and reacted here. All right, that was easy. B are catalysts. They come in as a reactant and leave as a product. I actually don't see any this time. Because A, we see, never leaves as a product. B is never a product. And Y is never a product. Now, Y is a product of a previous equation, but that makes Y an intermediate, not Y being a catalyst. So if we have like an E here and an E here, that's commonly what a catalyst would look like. But, sorry, we don't have any. Okay? Determine the overall balance reaction. Well, if we add up on the left side, we get that. And basically our product's going to kind of put it vertically. When we add all those up, we get that. Now, I don't really recommend normally doing this vertically. I just kind of ran out of room. But you can see that there's some compounds that appear on both sides. All we got to do is cross those out. They write whatever's left. I have an X. We have an X. Y. Y. That's it. So we combine like terms, and we get 2A plus 2B produces C plus D. And see, this is really the balanced equation we'd have. But that doesn't really tell us anything about our rate law or anything. It doesn't give us an idea of really what's going on. So we got to actually find our rate law for this. Now, our rate law is just going to base off our slow step. Well, that's not too bad. That can get us rate equals K times XB. Now, here's the kind of slight issue. Rate laws are based off the reactants of an equation. X isn't either of our reactants, which means kind of got to do a little bit more work. What you basically can tell, though, is kind of when you look up here, we get X by producing 2A. It's kind of like in math equal, kind of a little substitution. Which means our slow step, we can kind of more think of it as A plus B producing CY. Because again, that X is kind of an intermediate. Which means our rate law then actually turns into K A squared times B. Now let me kind of say that again. Our slow step got us XB. XB though, or X is an intermediate, and these need to be reactants. Well, in the previous equation, we basically saw that we got X by combining two A's. Which means that instead of basically X plus B, it's kind of like saying A plus B. Well, when we get by that, we get 2A plus B, which gives us A squared B. Now, this makes a decent bit of sense, but notice this is not the same as our balanced equation. So while, yes, there's a 2A for the squared, there's not a squared B. So rate laws may be related to equations, but they don't actually deal directly with balanced equations. All right, though, that's how you do reaction mechanisms. That's our video. Thanks for watching.